So here we go. We've taken our quiz over graphing. Let's talk more about quadratic equations and what can we do with them. We want to be solving quadratic equations, but the first thing we need to worry about is how to break up a quadratic equation. So before I can solve, I want to talk about factoring. I want to factor quadratic equations. So the question is, what does it mean to factor something? To factor something means to unfoil it or unmultiply it, kind of like division, but not exactly. I want to unmultiply, unfoil this equation, x squared minus 12x minus 28. I like to use this little chart. When I use this little chart, I want to remember that this is in the form of ax squared plus bx plus c. And since it's in my standard form and a is 1, I want to put my c here and my b here. Now, c is what multiplies. When I multiply, foiling, C is what things multiply to B. B is what they add to come up with. Now, where does that come up with? I'll talk more about that. But in this, my C is negative 28, and my B is negative 12. And the question is, what multiplies to be negative 28 and adds to be negative 12? So I'm going to start this by asking what multiplies to be negative 28. Well, that's 1 times 28. 2 times 14. 3 times, it does not divide into 28 evenly. 4 times 7 is 28. 5 does not divide into 28 evenly. 6 does not divide into 28 evenly. 7 is already over here, so I have a repetition. These are all my factors of the number 28. Now, that being said, this is positive 28. 1 times 28 is positive. 2 times 14 is positive. 4 times 7 is positive. I want it to multiply to be negative 28. So now I have to look at the negative 12. What makes my 28 negative depends on what this negative 12 is. 1 and 28, there's no way to get 12. 4 and 7, I can get 11, but I can't get 12. 2 and 14 will give me 12. But I want negative 12, so it's negative 14 because negative 14 plus a positive 2 is a negative 12. So these are my two factors that I want to use. And with that, I can say, and my form is always the same, x, since it's a positive 2, it's plus 2. Since it's a negative 14, it's minus 14. X plus 2 times x minus 14. This is my two binomials that FOIL out to give me x squared minus 28, minus 12x minus 28. How do I know? Let's FOIL it. First, x times x is x squared. What's in green is my answer, and blue is my checking. First is x squared. Outer is negative 14x. Inner is positive 2x. And last is negative 28. Look what I just did. This negative 28 goes exactly with this negative 28. The negative 14 and the 2 are my factors I came up with over here. And negative 14 plus 2 is the negative 12 that I came up with there. So that's where all these parts lay in. These are all the parts that I make up when I FOIL, and I'm just doing it backwards now by unfoiling it. So my answer to what is the factor is this right here, x plus 2 times x minus 14, but this is why it works. Let's try another one. Let's factor x squared plus 2x minus 48. Again, I want to start the same way with my little table. My letter C goes here, my letter B goes here. What multiplies to be C and adds to be B? My C is negative 48. My B is the number 2. So the question is, what multiplies to be negative 48 and adds to be 2? Well, what multiplies to be negative 48? 1 and 48. Again, one of these is going to have to be negative. 2 and 24. 3 times 16. 4 times 12. 5 does not go into 48. 6 times 8. 7 does not go into 48. 8 goes into 48 6 times, but that's a repetition. So these are all my factors. So that tells me somewhere in here I should get a 2. Now, like I said, since it's a negative 48, one of my two numbers has to be negative. I want my answer to be a positive 2. So 1 and 48 won't give me 2. 2 and 24 won't give me 2. 3 and 16 won't give me 2. 4 and 12 won't give me 2. But 8 and 6, 6 and 8. Since I want the number to be positive, it's going to be negative 6 plus 8 will add to be a positive 2. So those are my two factors, negative 6 and 8. So I can come back over here and say this is x minus 6 times x plus 8, and that's my answer. Now I'd like to check it, and I'm going to check it by FOILing. Again, first, x squared. Outer, 8x, just like the 8 over here. Inner, negative 6x, just like the negative 6 over here. And last, negative 48. 8x minus 6x is 2x, so I have my answer, x minus 6 times x plus 8. Let's try a third one. X squared minus x minus 2. Same idea. What multiplies to be c and adds to be b? My c is a negative 2. My b is a negative 1. What multiplies to be negative 2? Well, that's 2 and 1. One of them needs to be negative. One of them needs to be positive so that I can have a negative 2. Well, negative 2 plus a positive 1 is negative 1. So negative 2 and 1 are my factors. So this is x minus 2 and x plus 1. This is my answer as far as I'm aware. I'm going to check it by FOILing. First, x times x is x squared. Outer, x times 1 is 1x. Inner, negative 2 times x is negative 2x. Last, negative 2 times 1 is negative 2. Again, here is my two factors, my 1 and my negative 2. I add those, I get negative 1x. I already got my negative 2. So what is in red is my answer, x minus 2 times x plus 1. I want to do one other example before we go to our next step, because this is a doozy that you have to be careful of. So here we go. What multiplies to be c and adds to be b? My c is 14. My b is negative 5. So the question is what multiplies to be 14 and adds to be negative 5? Well, what multiplies to be 14 is 1 and 14 and 2 and 7. 3 won't go, 4 won't go, 5 won't go, 6 won't go, 7. 7 times 2, so I have a repetition. There are my two factors, 1 times 14, 2 times 7. Well, 1 and 14 won't give me 5. If I have 2 plus a negative 7, that will give me negative 5. But here's the problem. 2 times a negative 7 is negative 14, not positive 14 like I want. So I cannot get this to work. I can't find the right way. 2 and 7 won't add to be negative 5. 2 times a negative 7, which will add to be a negative 5, won't multiply to be positive 14. So I have to say that for now, this cannot be factored. Now, this will happen every once in a while, but it won't happen extremely often. So I just have to be aware of that. You have two more here. I'd like you to try to factor out, see what you can come up with. I will have the answers in class tomorrow. One of these is factorable. One of these is not. See what you can come up with. Now, what if I change things around. This is the next step. I've done my normal factoring where it was in the form of x squared plus bx plus c. And my a, as I had said, was 1. What happens when a is not 1? What happens when a is a different number? I can do things fairly similar, but I have more steps I have to do. I start with my same box as always. But instead of saying C, I want A times C. And my B stays the same. What multiplies to be A times C and adds to be B? So here, A and B multiply to be 30. So what multiplies to be 30 and adds to be negative 17? Well, what multiplies to be 30 is 1 and 30. 2 and 15, 3 times 10, 4 does not go into 30 evenly, 5 times 6, and then I have a repetition because 6 and 5 gives me a repetition. Those are all my factors. What will give me 17? Well, remember, I want a negative 17 and a positive 30. So that means all of these would have to be either both positive, well, they both have to be negative. So when I add these, negative 2 and negative 15 will give me negative 17. But here's the problem. I have this pesky number 3 in front of here. I have to figure out how to get that 3 into my problem, into my factors. I can't have both my I can't have both of my factors be x, because when I FOIL this out, I get x squared when I want 3x squared. So I have to throw in a 3. The question is, where does that 3 come in? I'm really not sure. So at this point, I have to do a special form where I'm going to put my 3x, the 3 comes from here, and a 3x, and I'm going to make 2 fractions. My denominators are going to be my 2 factors I came up with over here, this negative 2 and this negative 15. And the really slick thing is I want to reduce my fractions. This first fraction cannot be reduced, so it becomes my factor 3x minus 2. This one can be reduced. This can be reduced. 3 goes into 3 once, so I get 1x or x. 3 goes into 15, negative 5 times. And that reduced, leaving the factor x minus 5. Now, why does that work? Well, what that does is it reduces it so that when I FOIL this out now, my first will be a 3x squared, just like I have up here. My outer will be a negative 15x, just like I have over here. My inner will be a negative 2x, just like I have over here. And my last will be my positive 10, just like I have up here. All the pieces fit together, all the pieces work, but you have to throw in that extra little a, and you have to throw in these weird little fraction things here, but it does give me my answer of 3x minus 2 times x minus 5. Let's try a different one. I want to do the same process, the same idea. A does not equal 1, so I have to use this special method, which we call the California method. Why? I don't know, because I guess it came from California. That's what Mr. Moore told me, and what Mr. Moore says is gold. So A is not 1, so it has to be A times C, what multiplies to be A times C, and what adds to be B. A times C is 4 times negative 3, which is negative 12. My B is still a negative 4. Because this is my A and this is my C. Well, what multiplies to be negative 12? Well, that's 1 and 12, and I'll worry about the negative in a little bit. 2 times 6, 3 times 4. 5 does not work. Well, 3 times 4 and then 4 times 3, that's a repetition. So I don't have to move on to, because those are all my factors. Now I want something to add to be a negative 4. 1 and 12 won't work. 3 and 4 won't work. 2 and 6 will give me a negative 4. If the 6 is negative, 2 plus a negative 6 is a negative 4. So there are my two factors, 2 and negative 6. But since this is California method and I have this pesky 4 in the front, I need to do some reducing. So I take that 4 and put it with an x and put them both over my factors, the two factors I came up with, the 2 and the negative 6. Now both of these are going to reduce. 2 goes into the 4, 2, so I get 2x. 2 goes into 2, 1, so I get 2x over 1. If something cancels out completely, I want to put a 1 in its place because this gives me the factor 2x plus 1. 2 goes into 4 twice, so that's 2x. 2 goes into 6 3, so that's negative 3. And so that's 2x minus 3 is my factor. And again, the whole purpose of this is this 4. If I don't have this 4 here, I don't have to worry about it. I have to find a way so that when I FOIL out, I'm going to get 4. 2x times 2x is 4x squared. And so my answer, my factor is 2x plus 1 times 2x minus 3. If I FOIL this out, here's the answer I would come up with. Okay? I'm going to do one more example, letter C. Again, A is not equal to 0, so I have to use the California method. A times C, what multiplies to be A times C, and what adds to be B. A times C is 2 times negative 3, which is negative 6. And my B is this hidden 1 right here. What multiplies to be 6? Well, that's 1 and 6, 2 and 3. Which of these will add to be a positive 1? Well, I need to have a negative somewhere. So if the 2 is negative, I get negative 2 plus 3 is positive 1. Those are my factors, negative 2 and 3. I have, because A is a 2 and not a 1, I have to set up my fractions, 2x and 2x. I want to put my two factors underneath. This one reduces. 2 goes into 2 once, so I have 1x. 2 goes into negative 2 once, so I have negative 1. So this is the factor of x minus 1. This reduces. I don't need to reduce that, so that is the factor 2x plus 3. If I were to check this by FOILing this out, I would get first of 2x squared, outer of 3x, inner of negative 2x, and last of negative 3. Again, I have my 3 and my negative 2. And if I add those, I get 2x squared plus x minus 3. So this is my answer. Those are your problems. That is your notes. I will see you in class tomorrow.